This is the solution to the 2021 Leaving Cert Higher Level Maths Paper 1 from question 1 through to question 10. If you want to skip to a particular question, just go down to the description box below and click on the particular question and it'll bring you to that question. If you like what you see, please subscribe to my YouTube channel.
In this video, we're looking at question 1 on paper 1 of the 2021 Leaving Cert Higher Level paper. This is the complex numbers question. The first part has it set up as a fraction equal to 0 plus ki. A couple of different ways you can do it. You can use your division of complex numbers if you want, multiply the denominator by the conjugate of the denominator, or you can use your identities similar to your algebraic identities that you might have studied. So that's the method I'm going to approach here. So I'm going to have 4 minus 2i all over 2 plus 4i equal to 0 plus ki. And what I'm going to do is I'm going to put that 0 plus ki over 1 and I'm going to cross multiply. When I multiply 1 by 4 minus 2i, I get 4 minus 2i is equal to 0 plus ki multiplied by 2 plus 4i. Now you can drop that 0 if you wish. So that's going to give me 4 minus 2i is equal to ki multiplied by 2, which is 2ki. And ki multiplied by 4i is plus 4ki squared. Next thing I'm going to do now is compare the reals with the reals and the imaginaries with the imaginaries. First of all, though, I'm going to isolate this I squared. I'm going to turn that into -1. So that's giving me 4 minus 2i is equal to 2ki plus 4 times -1. And to rewrite that, it's 4 minus 2i is equal to minus 4 k, there should be a k there, minus 4k plus 2ki. And like I said, now I'm going to match the reals with the reals. So positive 4 matches with negative 4k, and then I'm going to match the imaginaries with the imaginaries. So I'm going to come up here to the right hand side. So that means, so therefore, I'm sorry about that, 4 is equal to minus 4k, so k is equal to dividing both sides by -4, so k is equal to -1. Now you can check it with the imaginaries if you want. Let's just check it. So we have minus 2i is equal to 2ki. I'm going to divide across by I, so I'm cancelling the I from both sides. So that leaves me with minus 2 is equal to 2k. So k is equal to -2 over 2. So k is equal to -1. So we've done it both ways. You don't need to do both. But that's the solution to question 1a. Moving down now to part B. So part B wants us to find the square root of minus 5 plus 12i in the form a plus bi. So what I'm going to do there is let them equal to each other. So I have a plus bi. And I know that that is going to equal the square root of -5 plus 12i. Now to get rid of a square root, we know we square both sides. So I want to isolate that square root. So I'm going to multiply across by the square root of 2, or from the square of 2. So that's giving me a plus bi, all to be squared, is equal to -5 plus 12i. Now I'm going to multiply out that square on the left hand side. So it's a plus bi times a plus bi. Equal to -5 plus 12i. When I multiply out my two brackets on the left, I get a squared minus b squared plus 2abi equals -5 plus 12i. Now just watch when you're multiplying out those two brackets that you will get plus bi squared, and the I squared will turn into -1, so that's where the minus b squared will come from. Again, I'm going to use my identities. I'm going to pair up the reals with the reals and the imaginaries with the imaginaries. So I have a squared minus b squared is equal to -5, so that's the first thing I know. So therefore, a squared minus b squared is equal to -5, and I also know the imaginary parts. I have positive 2abi is equal to 12i. If I look at the left hand side, the real parts first of all, I'm going to isolate, I'm just going to have it as a squared. You can have it as b squared equals 2 if you want. I'm going to go a squared is equal to negative 5, moving over to minus b, or adding b squared to both sides, gets me minus 5 plus b squared. On the imaginary parts, I'm going to divide across by I, so they'll cancel. So that leaves me with 2ab is equal to 12. And I want to write a is equal to, so I'm going to divide across by 2b. So a is equal to 12 divided by 2b. Now again, I'm writing them in terms of a and b. You can go the opposite, so it's up to you. So when I divide that in, I can simplify that fraction. 12 over 2 is the same as 6 over 1b, or just 6 over b. So I have now written a as 6 over b, and I have a squared written as minus 5 plus b squared. So what I'm going to do now is I'm going to use a little bit of simple substitution. I'm going to sub in my value for a into the real part. So I have a squared equals minus 5 plus b squared. And what I'm going to do is I'm going to sub in my 6 over b for a. So subbing in my 6 over b for a, so 6 over b squared. And that is equal to minus 5 plus b squared. And when I square out my 6 over b squared, that's going to give me 36 over b squared is equal to negative 5 plus b squared. I'm going to put that as a fraction, so I'm going to put it over 1, and again I'm going to do some cross multiplication. Now when I cross multiply, that's going to give me 36 is equal to negative 5b squared plus b to the power of 4. And I'm going to move everything to one side, so rearranging the right hand side, that gives me b to the power of 4 minus 5b squared minus 36 is equal to 0. And I'm just going to put the 0 to the rear, so b to the power of 4 minus 5b squared minus 36 is equal to 0. Now, it's starting to look like a quadratic, except the highest degree is to the power of 4. So I'm going to use some u substitution here. So I'm going to let u is equal to b to the power of 2. So I can now rearrange my equation there to become u to the power of 2 minus 5u, because u to the power of 2 is equal to b squared, and minus 36 is equal to 0. Now again, I'm using u substitution. You don't have to. You can find a different way if you prefer. If I find my factors, I'm going to get the multiples of 39 that add to negative 5, which are negative 9 and positive 4. So therefore, u is equal to positive 9 and u is equal to negative 4. Okay, so we have our values for u. I don't need the value for u, I need the value for b. So I'm now going to solve for b. So I'm going to come up here to the right hand side. So I have u is equal to 9 and I have u is equal to negative 4. So therefore, to find the value of b, don't forget that u was b squared. So that means that b squared is equal to 9. So b is equal to the square root of 9. So b is equal to plus or minus 3. And u is equal to, b squared is equal to negative 4. So b is equal to the square root of negative 4, which is b is equal to the square root of 4i. So the square root of the negative will become I. So that's giving me b is equal to plus or minus 2i. So there's my two values for b. Now they're telling me a and b are real numbers. And now I just need to go off and find the values of a. So now find a. So I have my b. And don't forget, if we come over to the left hand side, how did we write a? We wrote a as 6 over b. So I'm going to use that knowledge over here. So remember that a is equal to 6 over b. And I'm basically going to sub in my values for b. So I have a is equal to 6 over positive 3. And a is equal to 6 over my negative 3. And that's going to give me a is equal to 2 and a is equal to negative 2. and they want our complex number in the form a plus bi, and when I fill that in, I get a as 2 plus my b as 3i, and I could also have -2 minus -3i. And they are my two complex numbers in the form a plus bi. So now we're looking at question 1c. Use de Moivre's theorem to find the 3 roots of z to the power of 3 is equal to -8. So when we're answering these, we need to first of all turn our complex number into polar form. So basically what we want to do here is we want to turn -8 plus 0i, so I'm bringing in that placeholder of an I, equals or times cos theta plus I sine theta. So that's what I just want to do. I want to change my 8 plus 0i into polar form. First of all I need to do is find my modulus, which is the square root of a squared plus b squared, which is giving me my a, which is my real part, which is -8 squared, plus my b, which is my imaginary, which is 0 squared. -8 squared is 64, and the square root of 64 is 8. So my or is equal to 8. Now I need to get my argument, or my theta, my angle. And my angle is found by finding the tan inverse of b over a. So tan inverse of b over a, which is 0 over -8. Now if you go to your calculator, this is going to throw up an error for you. So what we have to do is we have to sketch out what this would look like on our Cartesian plane. So I have just a very rough sketch here. So I have my reals and my imaginaries, and our complex number is -80i, which will be back here. So this would be my complex number. And what angle is that? Well, if I'm starting and I go backwards, I'm going back 180 degrees, or in radians, I'm going back pi. So my angle there is equal to pi, or 180 degrees. So that's what I have to do. I have to sketch it in order to find my argument. So filling in my information, so I have my original complex number, 8 plus 0i, is now equal to 8 times cos of theta plus I sine theta. Sorry, that should be a -8, shouldn't it? It should, and I have it at the top of the question there. -8 plus 0i is equal to 8 times cos theta plus I sine theta. Now, the question wants it to the power of 3, so that's -8 to the power of 3 is equal to 8 times cos theta plus I sine theta. Now, in order to isolate that power of 3, or to eliminate that power of 3, I need to multiply across by a third. So I'm going to change that. I'm multiplying both sides now by the power of 1 over 3. So 1 over 3, and I have to multiply the right-hand side by the power of 1 over 3. And on the right-hand side now, that's the side I'm going to look at, when I multiply 8 cos theta plus I sine theta to the power of a third, we're now going to use our de Moivre's theorem for that. So your rule is in your log table. So what it tells you to do is you bring down the power and you multiply it by your or, and then you multiply your angle, cos 1/3 multiplied by pi. Now I need to get all possible values for my complex number. So here now I need to add on plus 2n pi for all possible solutions or rotations of 360 degrees, plus I sine multiplied by a third times my angle of theta, of pi plus 2n pi. So that's my full rotation, as we said. So now in order to solve this, we are going to look at what the power is. It's z to the power of 3. So we need to test this now for n is equal to 0, n is equal to 1, n is equal to 2. So I'm now going to come down and sub in n as 0. So n as equal to 0. That's going to give me, so 8 to the power of 1/3 is 2. So that's going 2 times cos 1 over 3 times pi. When I put in my 0, let's put it in just for this one. So again, that'll just turn out to be 0, but we'll do it nonetheless. Plus I sine 1 over 3 times pi plus 2 times 0. Okay, so when we evaluate that, it's going to work out as 2 multiplied by cos 1/3 theta is coming out as a half on my calculator. Just make sure your calculator is in radians, plus 1/3 square root of 3 over 2. Multiplying in my 2, so 2 multiplied by half is 1, and 2 multiplied by root 3 over 2 is just root 3i. So there's my first complex number. I'm now going to do the same thing again for n is equal to 2. So n is equal to 1 first of all, sorry, not 2, which is going to give me 2 times cos of 1/3 times pi plus 2 multiplied by 1 multiplied by my angle plus I sine 1/3 pi plus 2 multiplied by 1 multiplied by pi. Okay, so this is testing it for n is equal to 1. When I evaluate that, I get 2 times cos of 1/3 multiplied by 3 pi, wouldn't it? So that's giving me minus 1 plus 0i. And multiplying into 2, that gives me negative 2 plus 0i, which is just the same as negative 2. So there's my second complex number, and I now need to test it for n is equal to 2. So n is equal to 2, and I go through my motions again. So 2 multiplied by cos 1/3 times pi plus 2 multiplied by 2 this time. Plus I sine 1/3 multiplied by pi plus 2 multiplied by 2. And that is going to give me 2 times, when I go to my calculator again, just make sure it's set in radians, it's giving me a half minus root 3 over 2. And when I multiply in my 2, that's giving me 1 minus root 3i. So my three complex numbers are 1 minus root 3i, minus 2, and 1 plus root 3i. This is the solution to question 2a. Given that x is equal to minus 3 is a solution to the modulus of x plus p is equal to 5, find the two values of p where p is an element of z, the integers. So what we're going to do here is, remember that the parallel lines there around the x plus p means the modulus, so you can have a positive or a negative solution. So you always turn your answer into a positive, so that's why it's written as x is equal to 5. But remember that that could equal to negative 5 originally. So we have x plus p is equal to 5. And it's telling us that x is equal to negative 3. So all I'm going to do here is sub in my minus 3 for x. So minus 3 plus p is equal to 5. Now, like I said, that could have been a negative 5. So we have minus 3 plus p is equal to 5. And we have negative 3 plus p is equal to negative 5. And all we have to do is solve both of those equations. So moving over the negative 3 or adding 3 to both sides, I get 5 plus 3. So p is equal to positive 8. And we also have p is equal to minus 5 minus 3. So p is equal to, sorry, that should be a plus 3. Minus 5 plus 3 is negative 2. So my two solutions, therefore, for p is equal to 8 and p is equal to negative 2. Now you can verify your answer by subbing in 8 into x plus p, and you should get 5 and negative 5. Okay, that is part A. Scrolling on down now to part B. So part B, x plus 4 is a factor of f of x, where x is an element of the reals and q is an element of z, which is the integers. Show that q is equal to minus 5 and then find the three roots of f of x. A couple of different ways you can do this. In order to find the other roots, you can use long division. But what I'm going to do here is I'm going to sub in my root. So first of all, they've given us one of the factors. So the first factor there they've given us is x plus 4. So they've given me x plus 4 as one of my factors. Now to turn that into a root, that's equal to 0, don't forget. So then one of my roots is moving over the positive 4, I get a negative 4. So that's my first root. So we've a couple of marks got there first of all. In order to show that q is equal to negative 5, I'm going to sub in that root into f of x. So it's telling us that f of x is equal to x cubed plus qx squared minus 22x plus 56. So in order to solve for q, I'm going to sub in my first root, which is minus 4. So that's going to find me f of minus 4 is equal to. So again, use brackets here for your calculator because we're using a negative 4 here. So I'm basically subbing in negative 4 for x. So that's going to be minus 4 cubed plus q times negative 4 squared minus 22 times x, which again is negative 4, plus 56. Okay, and solving that, minus 4 cubed is negative 64, plus q times minus 4 squared, which is 16, so 16q, and minus 22 by minus 4 is a positive 80, plus 56. Now this is equal to 0 because when you sub it into our cubic equation, it should satisfy it because it's a factor, so it should be equal to 0. So that's why I'm going to let this equal to 0. So minus 64 plus 80 plus 56 is getting me 80 plus 16q is equal to 0. So I'm just going to put the 0 at the back. So that's getting me 16q is equal to, well, when I subtract 80 from both sides, I get 16q is equal to negative 80. I'm going to divide across by 16, so q is equal to minus 80 divided by 16. So you can see here that q is equal to negative 5. So the question did want us to show that q is equal to negative 5. Well, we just have. Now I'm just going to scroll down and find my other two roots. So we have one of the roots, don't forget, we have it as negative 4. Let's find the other two. So what I'm going to do here is I'm going to divide my factor that they've given me, x plus 4, and I'm going to divide that into my cubic x cubed minus 5x squared. So I'm subbing in my minus 5 for q now, minus 22x plus 56. So I'm just going to divide this now, a bit of algebraic long division. Okay, so x into x cubed is x squared. I multiply it back down, x times x squared is x cubed, and x squared times 4x is positive 4x squared. I'm now going to change the signs, so that's becoming a minus, that's becoming a minus. X cubed, take away x cubed to 0, minus 5x squared minus 4x squared is negative 9x squared. I'm then going to bring down my minus 22x, and I'm going to go again. So I'm dividing x into minus 9x squared, becomes minus 9x, and multiplying minus 9x by x gives me minus 9x squared, and minus 9x by 4 is giving me minus 36x. Again, change the signs. This negative now becomes a plus this time, and minus 9x plus 9x squared becomes 0, and minus 22x plus 36x becomes a positive 14x. Moving down my positive 56, so it's 14x plus 56, and dividing x into 14x becomes plus 14. And multiplying it down for the last time, 14 multiplied by x is 14x, and 14 multiplied by 4 is positive 56. And I change my signs, so that becomes a minus and a minus. 14x take away 14x is 0. 56 take away 56 is also 0, so that's giving me a remainder of 0. Okay, so that's leaving us now with a quadratic equation. So my quadratic equation, my solution there for my division is x squared minus 9x plus 14. Now I'm going to factorize that, and when I factorize that, it's a straightforward enough one. Multiples of 14, which adds to negative 9. So that's getting me a 7 and a 2. And multiply to positive 14, but adds to negative 9. So they must be a negative and a negative. So there are my factors. Let's get our roots. So we have x minus 7 is equal to 0. And we have x minus 2 is equal to 0. So therefore, my roots are x is equal to 7 and x is equal to 2. So filling in my answer down here, my roots are going to be, well, my first one was minus 4 that we got at the start of the question. And my other two here now are 7 and 2. And that's the solution to question 2. This is a sample answer to the question 3 on paper 1 of the 2021 Leaving Cert Maths paper. So in question 3, it gave us a diagram of a cuboid, and it gave us the dimensions of the cuboid being x multiplied by y multiplied by z. They gave us the area of the 3 faces as per the diagram, and they wanted us to find the volume of the cuboid. Different ways that you could look at it. What I'm going to use here is the knowledge of prisms. So a prism is where you have a shape with the same cross-sectional area, and then I'm going to multiply it basically by the depth of the shape. So to get the volume of that triangular shape, I get the area of the face multiplied by the depth, and that's what I'm going to do here. So all I have to do on this question is basically I need to figure out either the value of z, the value of x, or the value of y, and multiply it then by its corresponding surface area of one of the sides. So what do we know? When we're trying to find the volume of a object, so of our cuboid here, our volume is going to be length multiplied by width multiplied by height. So in other words, in this shape, our length, width and height is x multiplied by y multiplied by z. So that's what we need to use. And all I need to do now is find either the volume of x, y or z, as we said. So what do we know? We know the area of our 3 faces. So look at the area of this particular face. So that is length by width, which would be x multiplied by height. So x multiplied by z is giving me an area of 2 root 2. If I come over and do something similar to the next face, so this front face here, that is going to be y multiplied by z. And it has an area of 8 multiplied by root 6, so 8 root 6. And then my third face on the top of the cuboid is going to be x multiplied by y, which is giving me an area of 4 root 3. So I'm just basically writing down what I know. Now, 2 of these have an x term in them, xz and xy. So I'm just going to manipulate those, and I'm going to divide across by z on the first one. So I have x is equal to 2 root 2 all over z. And on the third one here, I can also have x is equal to 4 root 3 divided by y. So I have 2 values for x. So that means that both of those are equal to each other. So that's something I can now state. So I can now state, so therefore, I now have 2 root 2 divided by z is equal to 4 root 3 divided by y. And I'm just going to use some simple cross multiplication now. And that is going to give me y times 2 root 2 is equal to z times 4 root 3. So I've just used some cross multiplication there, that's all. And I'm going to get y on its own. So I'm going to divide across by 2 root 2. So that means that y is equal to z, let's put that z in a bracket, 4 root 3, all divided by 2 root 2. So I'm dividing across by that 2 root 2 there. That's all I've done. Now, if you go to your calculator and divide 4 root 3 by 2 root 2, it simplifies as root 6. So therefore, y is equal to root 6 z. And you can put that z in a bracket. Just make sure that it's outside of the square root. So that's what we know. So what I'm going to do now is I'm going to come back to this middle section here. Y times Z is equal to 8 root 6. So let's write that down. So I'm going to come back over here and I'm going to take this section here. So I know that Y times Z is equal to 8 root 6. Now I'm going to make a substitution here. I'm going to substitute my value for Y that I got down here on the left hand side. So my value for Y is root 6Z. So I'm substituting now my Y for root 6 times Z. And don't forget then that that has been multiplied by this Z. And when I multiply Z by Z, we get Z squared. So that's giving me root 6 Z squared is equal to 8 root 6. And to get Z squared on its own, I'm going to divide across by root 6. So 8 times root 6 all over root 6. Root 6 divided by root 6 is just 1. So Z squared is equal to 8. And then my final solution for Z is going to be the square root of 8. So we now have the value of one of our sides. Now you can write that as 2 root 2 if you want. It's all the same. I'm just going to leave it there as root 8. So I'm going to come back up to my picture now. So I have found my Z to be root 8. So I'm just going to mark that in here. So I have Z as root 8. And what does that mean? So in order to get the volume of that box, it means that I'm now going to take the face of my top part of the box, so this one here, so that's the surface area of my cross-sectional area as we call it, and I'm going to multiply it then by the depth of the shape, which is this Z. So that's going to use my knowledge of prisms. So if I multiply 4 root 3 by root 8, I will get the volume of that shape. So my final answer is, so therefore my volume is going to be 4 root 3, I think was the area, wasn't it? It was 4 root 3 times root 8, and 4 root 3 by root 8 is giving me 8 root 6, and it doesn't simplify and it's in centimeters cubed. So that is the volume of that cuboid. So question 4a, prove using induction that the following is divisible by 7. So you have your 3-step process here. First of all, we need to show that it's true for n is equal to 1. Then you have your assume true for n is equal to k, and then you show true for n is equal to k plus 1. So like I said, show true for n is equal to 1 is my first step. So all I'm doing here is I'm subbing in 1 for n. So that's 2 to the power of 3 times 1, subtract 1 plus 3. That's giving me 2 to the power of 3 subtract 1 plus 3, which is 2 to the power of 2 plus 3. 2 to the power of 2 is 4 plus 3, which is giving me 7. And 7 is divisible by 7, so therefore true. So that's our first step done. Step 2, we are now going to assume true for n is equal to k. All I'm doing for step 2 is I'm subbing in k for n. So that's going to become 2 to the power of 3 times k, subtract 1 plus 3, which is 2 to the power of 3k, subtract 1 plus 3. So I'm assuming that that is divisible by 7. Moving on now to step 3. And step 3 is going to be prove true for n is equal to k plus 1. So this time for n, I'm subbing in k plus 1. So that's going to give me 2 to the power of 3 times k plus 1, and then put in my plus 1, add 3. A little bit of tidying up here. I'm just going to multiply in this 3 into the bracket. So that's giving me 2 to the power of 3k plus 3 plus 1, and then plus my 3. What can we do from there? I'm just going to, sorry, that's a negative 1 outside the bracket. Sorry, not a plus 1, that's a negative 1. Let me just change that. I'm just going to rearrange the order there, the 3 and the -1. I'm just going to change the order of that, and you'll see why in a second. So that's 3k minus 1 plus 3 plus my positive 3. Because what I'm trying to do here is I'm trying to make this somewhat the same as up above with my step 2. So I'm trying to achieve 2 to the power of 3k minus 1. So that's all I'm trying to do here. So if I use my rules of logs on page 21, this is the same as 2 to the power of 3k subtract 1 times 2 to the power of 3 plus my 3. So I'm just bringing in that 2 to the power of 3 there. Again, from my log tables, first log there on page 21. Next thing I'm going to do is I'm going to work out 2 to the power of 3. So that's 2 to the power of 3x minus 1 times 8 plus 3. Again, I want this to be divisible by 7. So I'm just going to rewrite the number 8 now as 7 plus 1. So 2 to the power of 3k subtract 1 times 7 plus 1. That's the same as 8. That's all I've done. And my next step is I'm now going to multiply that into the bracket. So that is giving me 7 times 2 to the power of 3k subtract 1 plus 1 times 2 to the power of 3k subtract 1. So I don't need to put that 1 outside. You can if you want. And then don't forget your constant of 3. Okay, so we are practically finished here. We just need to make some conclusions now based on our work. So what do I know? Look at this part here. I know that this is divisible by 7 because 7 is a factor. So the 7 there, the factor of 7, 7 times anything must be divisible by 7. So that's the first part done. We know that that is divisible by 7. And if we come to the next part, from step 2, we assumed this to be true. Okay, so if you scroll back up there, you can see from step 2, we assume that 2 to the power of 3k subtract 1 plus 3 is divisible by 7. So what does that mean? So our final conclusion, just to make sure we make our conclusion here at the end. So therefore, we can now conclude that 7 times 2 to the power of 3k subtract 1 plus 2 to the power of 3k subtract 1 plus 3 is divisible by 7. And the reason why this is, so we said that it is since true for n is equal to 1, assumed true for n is equal to k, and proved true for n is equal to k plus 1, it is therefore true for all values of n when n is a positive integer, a natural number. So a little bit messy there, the handwriting, apologies for that, but that is our proof by induction to question 4a. I'm just going to zoom out here a little bit, just if we need to take a larger view on it at home. So we'll now scroll down onto question 4b. So we're into patterns. They've given us this sequence, and it is an arithmetic sequence where p is an element of n. Find the nth term, tn, in terms of n and p. So from our log tables, we know the formula for an arithmetic sequence is tn is equal to a plus n minus 1 times d. From the above sequence, we know that our a is our first term, which is p, and our difference, well, just take any two consecutive terms. So I'm going to take term 2, and I'm going to subtract the previous term, term 1. So it doesn't matter which two terms you take away as long as they're consecutive. So you can go term 3, take away term 2, term 5, take away term 4. So p plus 7 minus p is giving me a difference of, well, the p's will cancel, so my d is just 7. So if I sub that into my formula, Tn is equal to A, which is my P, plus n minus 1 times D, which is 7. Just tidy it up now by multiplying in that 7 into the bracket. So that's giving me Tn is equal to P plus 7n subtract 7. And that's our nth term. Part 2, find the smallest value of P for which 2021 is a term in the sequence. So let's see what we have here. So we have our formula for Tn, which is 7n plus P minus 7. So that's from part 1 above. So I've just rearranged that. That's the same as 7n plus P minus 7. So I've just rearranged them. And that's equal to 2021 because 2021 is a term in the sequence, so it must satisfy it. What can we do there then? I'm going to move over this minus 7, which leaves me with 7n plus P is equal to 2021. Add 7 to both sides will leave me with 7n plus P is equal to 2028. I'm going to move over to P. Let's see what that gives us. 7n is equal to 2028 minus P. So that means therefore that n is equal to 2028 over 7 minus P over 7. So I'm dividing both sides by 7 there, which is the same as a decimal, what's that, 289.7 reoccurring minus P over 7. There's a little bit of trial and error here to help us. So we know that if we use that 289 now as our value for n, so I know it's not the exact value for n, but we're trying to get the smallest value of P. So with a little bit of trial and error, so let's just see what this gives us. So if I take my 7n plus P minus 7, and if I sub in 290, let's just, because I'm rounding to 289.7 up to 290. So that gives me 7 times 290 plus P minus 7. Now that's giving me, what's that giving me? 2030 plus P minus 7. So that'll give me 2023 plus P, but that can't work. So I'm going to put an X on this. And the reason for it is, in order for me to make P 2023 become 2021, that would mean then that P would be negative. So that would give me, so again, don't forget, if this was equal to 2021 and I move that over, that would give me P is equal to negative 2. And P can't be negative 2 because at the top of the page there it says where P is an element of n. So I can't have that. So that's when n was 290. Let's see what happens when P is equal to 289. So that'll give me 7 times 289 plus P minus 7, which is giving me 2023 plus P minus 7. Again, I'm trying to get to 2021. Little bit of tidying up here gets me 2016 plus P equals 2021. Moving over to 2016 gives me a value of P is equal to 5, which does work because P is an element of n. Yeah, so find the smallest value of P. That's the smallest value I can find. Maybe there's other ways of doing it, but hopefully that will work. That's question 4. Paper 1, question 5a, the derivative of f of x can be expressed in the form f-x as complete the square form, where a, b and c are elements of the integers and x is a real. Part 1, find the value of a, the value of b and the value of c. So first of all, as you can see here, we need to differentiate it because it's asking us for f dash of x. So we need to differentiate our function f of x. So they've given us f of x, which is 2x cubed plus 6x squared minus 12x plus 3. And we now need to differentiate that. So f of x, f dash x is going to be, well, 3 times 2 is 6, x squared plus 6 times 2 is 12. Reduce my power, just becomes to the power 1. And then minus 12, and we drop the constant So 6x squared plus 12x minus 12. And we need to write that in the complete the square form. So first of all here I'm going to factorize out something that's common. We can factorize out the 6. So I'm going to rewrite it as 6 times 1x squared plus 2x minus 2. So all I've done is I've just factorized out the 6. Then I'm going to do a little bit of work with what's inside the bracket. So it's going to be, well, my first step of completing the square is always taking the coefficient of the x, which is 2, halving it or dividing by 2, which is 1, and squaring it. So you divide by 2 and square your answer, which is 1. So 2 divided by 2 is 1, 1 squared is 1. So I'm going to rewrite my quadratic then as x squared plus 2x, and I'm going to add on that 1, and I'm going to subtract that 1, and then put back in my constant of negative 2. So as we know, we haven't done anything wrong there. All we've done is added and subtracted 1, which gets me back to 0. Then I'm going to focus in on the x squared plus 2x plus 1 part, and then the negative 1, negative 2. So I'm doing two separate sections here. So I'm going to factorize out x squared plus 2x plus 1. And when I factorize that, well, the factors of 1 are 1 and 1, and I have to get to positive 2. So it's simply just x plus 1 times x plus 1. And then when I go minus 1 take 2, I get negative 3. So that's quite simple. And then that's going to leave me with 6 times x plus 1 by x plus 1 is the same as x plus 1 squared, negative 3. My final step now is just to multiply back in that 6, which is going to leave me with 6 times x plus 1 all to be squared, and then 6 by negative 3 is negative 18. And I'm practically finished. All I have to do now is fill in my a, b, and c. My a is the factor, which is 6. My b is the plus 1. And my c, the constant, which is my negative 18. Okay, that is part A. Scrolling down now to part 2. If g of x is equal to 36x plus 5, find the range of values of x for which f dash x is greater than g dash of x. So you can see here that we're still into differentiation here. So let's just write down what they're asking us to find. F dash of x is greater than g dash of x. Okay, so when we write that out, we know from up above that f dash of x is the same as 6 bracket x plus 1 all to be squared minus 18. You can write it as the equation if you want. You don't need to write it in the completed the square form. I just am for this part. And that's greater than g dash of x. So if I differentiate 36x plus 5, I simply just get 36. All I'm going to do now is a bit of simple tidying up. I'm going to move that negative 18 over to the constant of 36. So that's leaving me with 6 times x plus 1 all to be squared greater than 36 plus 18. So that is 6 times x plus 1 all to be squared greater than 36 plus 18, which is 54. I'm going to divide across by that 6, so that leaves me with x plus 1 all to be squared greater than 54 over 6. 54 divided by 6 is 9, so that's leaving me with x plus 1 all to be squared is greater than 9. Now I'm going to focus in on how to get rid of a square. So to get rid of that square, I need to get the square root. So square root. So that's going to give me the square root of x plus 1 all to be squared is greater than 9 square root. Now we know that a square will cancel with a square root, so that's my left hand side dealt with. So that's just leaving me with x plus 1 is greater than the square root of 9, which is plus or minus 3, because 3 by 3 is 9 or negative 3 by negative 3 is 9. So I just need to solve for both positive 3 and negative 3. So I have x plus 1 is greater than positive 3, and I have x plus 1 is greater than negative 3. So I just need to do both of those out. So that is leaving me with x is equal to 3 take away 1. So that's giving me 2. and I also have x is minus 3, take away 1, so x is equal to negative 4. So there are my two solutions for x. It wants to find the range of values, so I just need to now just do a quick sketch here just to see what we're looking at. So if I plot those two roots, I have positive 2 and I have negative 4. So it's just a rough sketch here, nothing spectacular. And if we go back up to part A, it's a positive function, so that's going to be the U shape or parabola. So it looks something like that. And it wants us now to find the range of values where it is greater than g dash of x. So that's everywhere above the x-axis. So remember, in our question here, we're working with the greater than symbol. So I'm looking basically for everywhere above the x-axis here and here. So what are those values, or a range of values? So we could have x is less than negative 4, so everything below negative 4, so this region here. And we also have everything above 2, so everything greater than 2. So, and x is greater than positive 2. So that is the solution to part 2 of question 5. Now looking at part B. So the diagram below shows t, the tangent line to h of x, and it has a point where x is equal to pi over 6. A is the point 0k, where k is an element of the reals, and it is the cuts the y-axis. Find the value of k. So that's the aim of the game here, is to find the value of k. Just going to explain briefly what I'm going to do here before I get into it. So first thing I'm going to do is I'm going to differentiate my function for my curve. When I differentiate the function, I'm getting a formula for the slope of that curve at any particular point, or the rate of change. And by doing that, as I said, I'm going to get a formula for the slope of the curve. I'm then going to sub in the x-coordinate pi over 6, which is going to give me the slope of the curve at that particular point there. When I find the slope of the curve, what I'm then going to do is I'm going to find the equation of that line. And by doing that, I need to find 2 points. I need to have the point A, which is 0k, but I also need to know what is the point here where the slope is found. And in order to do that, I'm going to sub in my pi over 6 into the original function, and that will get me my y value here. So there's my 2 points on that tangent t, and from that then I'm going to form the equation of the line. So a bit of work involved in it, but that's just giving you a brief synopsis of what I'm going to do now. So like I said, first thing I'm going to do is I'm going to differentiate my function h of x. So h of x is equal to 2 sine times 2x. So I'm going to differentiate a trigonometric function here. So h dash of x is equal to, well, it's the chain rule here, so I need to differentiate the 2x becomes 2 multiplied by the factor at the front, so 2 times 2 is 4. Sine will become cos, and then my 2x. So differentiating 2 sine 2x becomes 4 cos 2 of x. Now, like I said, that is now our rate of change, a formula for the slope on this particular curve. Now, we know that pi over 6 sits on that curve. So what I'm going to do is when I sub in pi over 6, I'm going to find the slope at that particular point. So that's all I'm doing next. So I'm subbing in pi over 6. So that's going to become 4 times cos pi over 6. So that's all I'm doing there, is I'm subbing in that pi over 6. And then I'm going to evaluate that on my calculator, which is giving me, sorry, I've just lost my 2. Don't forget this 2 here. And when I do that out of my calculator, I get a slope of 2. So again, don't forget, when you differentiate, you're finding the slope. So the slope at that particular point here is 2. So the slope of that tangent is 2. So let's find the point now on that line. So we want to find that particular point. What is this coordinate? We know that it's pi over 6 something. It's not pi over 6, 0. 0 is the point on the x-axis. We need to find that y-coordinate. So all I'm going to do there now is I'm going to sub pi over 6 back into my original h of x. So h of x is equal to 2 sine 2 of x. I'm now subbing in pi over 6 back into that function. So h of pi over 6 is equal to 2 times sine times 2 of pi over 6. So that's what I'm going to do out my calculator. Again, at this stage, it's no harm to mention, just remember your calculator is in radians at all times here now. So therefore, h of pi over 6 is equal to, when I do that out in my calculator, I'm getting root 3. So that means that coordinate that I've marked there in green on my diagram, this coordinate is now going to be written as pi over 6 root 3. That's that coordinate. And you can now see that I have our tangent t, and it has 2 points now on that line. So all I'm going to do now is form the equation of the line. That's all I'm going to do now in order to solve for k. So the equation of the line, as we know from our log tables, so equation of line is written as y minus y1 is equal to m times x minus x1. Now I know a lot of information here. My 2 points I have, and my slope I also have. So subbing that in with the point that I know, the pi over 6 and the root 3, gets me y minus y1. My y1 is root 3, is equal to m, which is 2 times x minus pi over 6. And just tidying that up, I get y minus root 3 is equal to, multiplying in that 2 times x is 2x, and 2 times pi over 6 is 2 pi over 6, which simplifies down to pi over 3 if you want to write it like that. I'm just going to leave it as 2 pi over 6. I'm now just going to move over the root 3 to the right hand side. So that is getting me y is equal to 2x minus 2 pi over 6 plus root 3. Okay, so there's our equation of the line in the form y equals mx plus c. You didn't have to rearrange it like that, but now we're going to come back up to my picture. Remember now at this stage that the point A, 0k, sits on that equation of the line. So if I sub in 0 for x and k for y, we should solve that equation. So y is now changing to our k. So this, remember that this is xy. So that's going to become y, which is k, is equal to 2 times 0 minus 2 pi over 6, which again is pi over 3, plus root 3. So that means that k is equal to 2 times 0, which is 0. So that's minus 2 pi over 6 plus root 3. And I'm just going to come up here because I'm running out of space. So that means then that k is equal to minus 2 pi over 6 plus root 3 on my calculator is giving me 0.68. Now the question at the start said find the value of k, corrected 2 decimal points, and that's what we have. K is equal to 0.68. And that's the solution to question 5. Question 6. The diagram below shows the graph of h dash of x, the derivative of the cubic function h of x. Part A wants us to show that h dash of x is equal to minus 2x squared plus 4x plus 6. So we're basically doing this from the graph. Our graph here is a negative quadratic as we look at it. It would originally be a cubic before it was differentiated. From our graph, we know that the roots where it crosses the x-axis are going to be x is equal to -1 and x is equal to +3. I'm going to turn those roots now into factors. So our factors are x plus 1 and x -3. If we multiply those two factors, we'll get a quadratic equation. So I'm taking the first term, multiplying it by the second bracket, and taking the second term and multiplying it by the second bracket. That's leaving me with x squared minus 3x plus 1x minus 3. And when I tidy that up, I get x squared minus 2x minus 3. Now you can see that our function here on the graph is a negative quadratic. So what I need to do here to my solution is first of all multiply across by a -1 in order to turn it into our negative. So I'm just going to basically change the signs. I'm multiplying in that minus, which is giving me minus x squared, positive 2x, positive 3. Now we can also see that it's crossing the y-axis, the y-intercept is at 6, but as I look at my quadratic, it's positive 3. So I need to multiply that by a scale factor. So in order to get from 3 to 6, I need to multiply by 2. So I just need to multiply my quadratic equation here by 2. So when I multiply in 2, I'm getting minus 2x squared plus 4x plus 6. And you can see in the question they've given us minus 2x squared plus 4x plus 6. Now what I'm going to do here is just to do an extra little bit of verification here. I'm just going to prove my y-intercept. So at my y-intercept of 6, I'm going to let x equals to 0, because I'm basically looking at this point here of 0, 6, the y-intercept. So on my derivative, I'm going to find h of prime 0, which is equal to minus 2 times 0 squared plus 4 times 0 plus 6. And that's giving me 0 squared is 0, 0 times minus 2 is 0, 4 nothings are nothing, plus 6. So that is telling me that h prime of 0 is equal to 6. And that was my y-intercept as per the diagram. And that is question 6, part A. Scrolling down now to part B. So part B, using h dash of x to find the maximum positive value of the slope of the tangent to h of x. Now remember that when they give us h dash of x, the derivative of the function, which is minus 2x squared plus 4x plus 6, we basically have a formula for the general slope of my cubic function. So all I'm going to do here is, if I come back up to my graph, you can see from my graph, let's just erase some of this markings here, that the maximum turning point on that graph here is when x is 1. So I basically just need to find its corresponding y value there. So that's all I'm going to do. And in order to do that, I'm going to sub 1 in for x. So I'm finding h dash of 1. And that is equal to 2 minus 2 times 1 squared plus 4 times 1 plus 6. So I'm just subbing in my x coordinate, which is 1. And that is giving me minus 2 plus 4 plus 6, which is 10 take away 2, which is 8. And that is our solution then to part B. If we keep on scrolling down now to part C, it's telling us that the graph of h of x passes through the point 0, minus 2. Find the equation of h of x. Again, just to recap what we have here, h dash of x is the derivative of my original cubic function, which is minus 2x squared plus 4x plus 6. So we want to find what was our cubic function before it was differentiated. So what we're basically doing here is we're doing integration. We're going in reverse here. So I'm looking for the integral of minus 2x squared plus 4x plus 6. Now the important bit here is our constant, and we'll get to that in a second. So when I differentiate minus 2x squared, I'm going to get minus 2x, increase my power by 1, divide by my new power. Plus 4x, increase my power by 1, so 1 plus 1 is 2, divided by my new power is 2. The constant 6 will become 6x over 1, and then plus my c, which is my constant. I'm just going to divide in what I can there, so that's giving me minus 2x cubed over 3. You can make that a decimal if you wish. 2 into 4 is 2x squared, and 1 into 6x is 6x plus my constant. Now it's telling us in the question here that the point 0, minus 2 is on the curve. So I'm going to use that fact to find my constant, this c here now. So I'm going to sub in 0 for x, minus 2 for y, and I should find my constant. So my function, h of x, is equal to minus 2, sorry, that should be h of, it is h of x, yep. And I'm subbing in 0 for x, which is minus 2 times 0 cubed over 3, and my h of x, I was going to fill that in, my h of x is now my y value, which is minus 2, and that is going to be plus 2x squared, subbing in 0 for x, plus 6 times 0, plus my constant, which is giving me minus 2 is equal to, well, 0 cubed is 0, minus 2 times 0 is 0, 0 divided by 3 is 0. 2 multiplied by 0 to the power of 2 is 0, 6 times 0 is 0, plus my constant. So that means that my c, my constant, is minus 2. So therefore, my function, my equation of h of x is equal to minus 2x cubed over 3 plus 2x squared plus 6x plus my constant, which is negative 2. And that's our answer to part 3, or part C. Wanted us to find the equation of h of x. And that is the solution to question 6. Question 7. The tip of the pendulum of a grandfather clock swings initially through an arc length of 45 centimeters. On each successive swing, the length of the arc is 90% of the previous length. A part 1, complete the table below by filling in the missing lengths. So on the first swing, it's going 45 centimeters, and that's what they've given us. The second swing is 90% of the first swing, and they've told us basically in the diagram how to find that. It's 45 multiplied by 0.9. So that's all I'm going to do here to fill in the second box. I'm going to go on my calculator, 45 times 0.9, and that's giving me 81 over 2. Now you can fill these in decimal or fraction, whatever comes up in your calculator. So that's my first one. In order to get swing 3, I'm basically multiplying 81 over 2 by 0.9, and I'm getting the 729 over 20, and so on. I'm multiplying each successive answer by 0.9. So my fourth swing is 6,561 over 200. And my final swing on my calculator, it's coming up as a decimal, 29.5245. And that's A part 1. Nothing too stressful there, I don't think. A part 2, they've given us a formula for the pattern. Tn is equal to 45 times 0.9 to the power of n minus 1. Is the arc length of the nth swing. Find the arc length of swing 25, correct 1 decimal point. Basically all here you're doing is you're finding term 25. That's all you're doing. So for n, we're subbing in 25. So term 25 is equal to 45 times 0.9 to the power of 25 minus 1. So we're basically putting it to the power of 24 here. So that's giving me term 25 is equal to 3.58949, which the question wants to 1 decimal point. So term 25 is equal to 3.6 centimeters. Don't forget your units because you might lose that mark in the marking scheme. On the next page is part 3 to that question, and it's asking us to find the total distance travelled by the tip of the pendulum when it has completed swing 40. Give your answer in centimeters to the nearest whole number. So what I'm looking for here is basically the sum of all the terms, and I'm going to my log tables for my formula here now. So in my logs, I'm on page 22, and we're looking here at a geometric sequence or series because it's reducing by 0.9 each time. So it's not an addition. That's why we're going for the geometric. So I'm looking at the sum of the terms here. So the formula I'm taking here is Sn is equal to A times 1 minus r to the power of n divided by 1 minus r. And I'm just going to write down the information I know. A stands for the first term, which is 45 centimeters, and r stands for the ratio, and it's changing by 0.9 each time. So they're the two pieces of information that I need for my formula. It wants swing of 40, the sum of the 40, so I'm subbing in S of 40. N is going to be 40 in this case, and A is 45 as we said. 1 minus r, which is 0.9 to the power of 40. Close my brackets, just be careful filling the power. The power there is to the r, and it's divided by 1 minus r, 1 minus 0.9. So the sum of the first 40 swings is equal to 443.349. The question wants it to the nearest whole number. So again, just always double check what the question wants. So that's giving me 443 centimeters. And that's part 3. Scrolling on down now to part IV, it is telling us that swing P is the first swing which is an arc length of less than 2 centimeters. So every time I multiply by that 0.9, 0.9, 0.9, which swing will give me a length of an arc of just less than 2 centimeters. So I'm just going to write that mathematically. My formula for term n is 45 times 0.9 to the power of n minus 1, and I'm looking for it to be less than 2 centimeters. So it's not equal to 2, it's less than 2. All I'm going to do now is solve for n. So a little bit of algebra here now. So I'm going to divide across by the 45. Again, don't get stressed when you see a less than symbol. Just treat it like it's an equals. So it's 2 over 45. So I'm going to keep it as a fraction. That's the same as 0.4 reoccurring if you want. I'm then going to go to my log tables, and I'm going to use my knowledge of logs here on page 21. And on page 21, top right hand corner, it has a to the power of x is equal to y, which implies, or the same as, the log of y to the base a is equal to x. So that's page 21 on my log tables, and that's what I'm going to use here. So when I fill that in, I have log of y. My y is my 2 over 45 to the base of a, and my a is 0.9. And that is less than or equal to my power, which is n minus 1. I'm just going to type in log of 2 over 45 to the base 0.9, and that gets me 29.55 is less than n minus 1. And I'm just going to do a little bit of solving here now for n. Sorry, now the screen is just moving there, just to make a bit of space. So I'm going to add 1 to each side, or move over that negative 1. So that's giving me 29.55 plus 1 is less than n. So n is less than 30.55. Now it has to be a whole number here, obviously, for the number of swing. So the swing with an arc length of less than 2 will have to be 31. And the question is called swing P. So in other words, my n I'm now going to change to, therefore P is equal to 31. Now if you want to verify that, sub 31 back into the nth term, the 45 times 0.9 n minus 1, and you should see that it is less than 2. So you can verify that answer if you want. Okay, that is now the solution to IV. We're scrolling down now to part B. So B part 1, if the length of the pendulum is 1 meter, show that the angle theta of swing 1 of the pendulum is 26 degrees, correct to the nearest degree. Now I'm just going to draw out this pendulum. So my pendulum starts, say, from the left, swings then to the right, and it's going in this motion like this of the arc. So it's going like this, and it's telling us that the length of the pendulum, so this is the top of the pendulum, and it's coming down to here. So that has a length of 1 meter, and it's the same here. 1 meter, and it wants us to show that it has an angle here, theta, of 26 degrees. Now we know that the length of the curve from the pendulum from the extreme left to the extreme right is 45 centimeters. So we know that that is the case. So what we're looking at here basically is we're looking at a sector, and they're basically getting us to use our knowledge of the length of the arc of the sector from page 9 in our log tables. And the length of the arc in our log tables is given by the formula 2 pi r times theta over 360. Now what I'm going to do here is I'm not going to work with the 26 degrees. I'm going to prove that it is 26 degrees. I'm going to find the answer to be 26 degrees. So filling in my L is my length of the arc, which is 45 centimeters. That is equal to 2 pi multiplied by my radius, which is 1 meter. So my 45 centimeters here, I'm actually going to turn it into meters, which is 0.45 meters. So I'm going to put a 0 point in front of my L here. So I'm working either in meters or in centimeters, but you can't mix it. So I'm going to work in meters here. And it's 2 multiplied by pi multiplied by 1 multiplied by theta over 360. And that gives me 0.45 is equal to 2 by pi by 1 is 2 pi times theta over 360. Again, a little bit of algebra here. I'm going to divide across by 2 pi, and that is giving me 0.45 over 2 pi. So I'm dividing both sides by 2 pi there, basically. And that is giving me a fraction equals to a fraction. Different ways you can do this here. In order to simplify my fraction equals to fraction, I'm going to cross multiply. So that's giving me 0.45 times 360 is equal to theta times 2 pi. And that then, in order to get theta on its own, I'm going to again divide both sides by 2 pi, which is giving me 0.45 times 360 over 2 pi. And when I type that on my calculator, I get 25.78 degrees, and the question wanted corrected in nearest degree, so therefore theta is equal to 26 degrees. And that's what the question wanted us to prove. Different ways you could have done that question. That's just the flow of the algebra that I did it, but you can do it slightly different. Looking now at part 2. Hence, find the total accumulated angle that the pendulum swings through, i.e. the total sum of all the angles if it swings through until it stops swinging. Give your answer correct to the nearest degree. So we're back to patterns here. Think about it here. So you're looking for all of the swings. So there's infinite amount of swings basically until it stops. That's the way I'm going to look at it. So I'm going to page 22 in my log tables, and I'm using my sum to infinity formula here, which is S infinity is equal to A over 1 minus R. And again, writing down the pieces of information I know. My A is 26. That's my first degree. So we're talking in degrees here now because we're using part 1, B part 1 here. So the first angle on the first swing is 26 degrees. My R is my common ratio again, and it decreases by 0.9 each time, 90%. And when I fill that in then to my formula, I get S to infinity is equal to A, which is 26 over 1 minus 0.9, which is giving me 260 degrees. And that's the answer there to part 2. Let's have a look now at part B, part 3. And this is the last part of this question. Hence or otherwise, find the total distance travelled by the tip of the pendulum when it has moved through half of the total accumulated angles. Give your answer in centimetres correct to the nearest integer. Okay, so the first part of this question is telling us when the tip of the pendulum has moved through half its accumulated angle. So we're looking at this part first. Now the total angle, as we found from part 2, was 260 degrees. So basically what we're looking at here is our accumulated total to be half of that, which is 130 degrees. So that's the first thing we need to do. Now what I'm then going to do is I'm going to go back to the sum of all my angles formula. Sn is equal to A times 1 minus R to the power of n all over 1 minus R. So I'm coming back to this formula here. And what I want to do basically is find the value of n, the amount of swings it takes to get to that accumulated total of 130 degrees. So what I'm going to do here again is I'm going to sub in my A, my R, and my N. So my A is going to be my first angle, which was 26. My R then is going to be 0.9. That's consistent throughout this whole question. So I'm subbing in now Sn, which is the total degrees, which is 130 degrees, equals A, which is 26, times 1 minus R, which is 0.9, to the power of n. That n is what I'm trying to solve for here now, all over 1 minus 0.9. So that's giving me 26 times 1 minus 0.9 to the power of n, all over 0.1 is equal to 130. I'm just putting that 130 to the rear. It's just the way I do the questions. I'm putting that over 1, making a fraction equals to a fraction, solving two fractions, cross multiply. So that's giving me 26 times 1 minus 0.9 to the power of n times 1, which remains as 26 bracket 1 minus 0.9 to the power of n, is equal to 130 times 0.1, which is 13. Okay, next thing I'm going to do is I'm going to divide across by 26 to isolate that power of n as much as I can. So that's equal to 13 over 26, which is a half. So that's 1 minus 0.9 to the power of n is equal to half, or 0.5. I now want to find the degree of n. Now, I don't need those brackets anymore, so that's the same as 1 minus 0.9 to the power of n is equal to 0.5, because I've gotten rid of that 26. I'm now going to move over that 1, or subtract 1 from both sides. So that's giving me 0.9 n is equal to 0.5 subtract 1. So that's minus 0.9 to the power of n is equal to 0.5 negative. You can multiply across by -1 there, or just change the signs. Because I have that equals, I can multiply across by -1 just to isolate, to get rid of that minus sign. We don't like working with minuses. Well, I don't. 0.9 to the power of n is equal to 0.5. I'm running out of space here, so I'm going to just bring it up here. So let me rewrite that. 0.9 to the power of n is equal to 0.5. Again, I'm going back now to my log tables on page 21. We've used it in the previous part here. The log, which has a to the power of x is equal to y, implies that the log of y to the base a is equal to x. So I'm using this rule again, and when I fill that in, I get log of 0.5 to the base 0.9 is equal to my power, which is n. And when I type in that log, I get 6.57, so 6.5788 is equal to n. Okay, so we're not done yet. That is just telling us the term which will give us a sum of half the total angles of 130 degrees. What we now need to do is, if we come back up to the question wants us to find the total distance travelled by the tip of the pendulum to get to that 136 degrees. So I'm now basically doing all this again. So I'm coming back and I'm taking my SN formula once again. So the total distance this time, a times 1 minus r to the power of n all over 1 minus r. Now things are slightly different here. Because we're talking about the total distance of the pendulum travelled, my a is now back to the 45 centimetres and my r is still the 0.9. So the first part of this question, just don't confuse it, this was talking about angles, but now we're talking about distance travelled. So subbing in my formula, Sn is equal to a, which is 45 times 1 minus 0.9 to the power of n, which we have from up above, 6.579, I'm going to call it here. I'm just going to go to 3 decimal points. And that is all over 1 minus 0.9. And when I type that into my calculator, I get Sn, well, S of 6.579 is what we're finding here. And I get 225.0044. The question wants it to the nearest integer, so that is giving me 225 centimeters in total. And that is the final part to question 7. Question 8a, the table in part A, part 2 below shows some of the values of the function h of x in the domain 0 to 75. A part 1, use h of 10 equals 30 to show that p is equal to 3.6. So this one is basic enough. Basically all they're getting us to do here is sub in 10 for our x and letting it equal to 30. That's about it for this first part of the question. So we're finding h of 10 is equal to 0.001 and my bracket, and it's cubed here, so 10 cubed minus 0.12 times 10 to the power of 2 plus p times 10 plus 5. When I evaluate that, 10 cubed multiplied by 0.001 is 1. Minus 0.12 multiplied by 10 to the power of 2 is 12, so minus 12. P multiplied by 10 is 10p, and then plus 5. And as I said, we know that our value here must equal to 30. And 1 take away 12 plus 5 is minus 6, plus 10p is equal to 30. And adding 10 to both sides, or moving over that negative 6, is giving me 30 plus 6, which is 10p is equal to 36. Dividing across by 10, 36 divided by 10 is giving me a value of p of 3.6. And that's what they wanted us to do there, to show in part A. Part 2, complete the table below and hence draw the graph of h of x in the domain 0 to 75 on the grid below. So what they basically want us to do there is you're subbing in the x value on each one. So they've done, let's say the second one there for us, they've subbed in 10 for x into my function, and they've got out a result of 30. So when I sub in 0, I get 5. When I subbed in 20, I got 37. When I subbed in 30, I got 32. 50, I got 10. 70, I got 12. So they're the couples, basically, my inputs and my outputs. I'm now going to just sketch them onto the curve, or onto the graph now. Okay, so my second last one is 70, 12. So I'm coming across from 12 to 70, which is roughly about here. And my final one is 75, 21.8. So 75, which is here. And I'm going up to 21.8, which is roughly around here. Okay, so there are my coordinates, and now sketch a freehand curve of the graph, which looks something like that. So as you can see in the question, if you just scroll back up, you can see that it is a cubic function, a positive cubic function, and that's what we've sketched. So always just take a step back, have a look at the function that you're asked to sketch, and by memory, does it look like what it should? And we can see here that it is a cubic. Okay, looking now at part B. So that's A done. B part 1 is telling us the function h of x can be used to model the height above level ground in meters of a section of the path followed by a roller coaster track where x is the horizontal distance from a fixed point. Find h dash of x, so that's our derivative of h. So basically all we're doing is differentiating the function here. So I'm multiplying my power, 3 by 0.01. Well, actually, let's just write down our original function here first of all. H of x is equal to 0.001 x cubed minus 0.12 x squared plus 3.6 x it was plus 5. And when I differentiate that, 3 multiplied by 0.001 is 0.003 x reduced my power. And this is the derivative of h of x. Minus 0.12 by 2 is minus 0.24 x, and I reduce my power. And then when I differentiate 3.6 x, I just get positive 3.6, and I drop my constant. And that's the derivative. Part 2, show that this section of track reaches its maximum height above level ground when x is equal to 20. So again, this is like your max and mins when you're doing your calculus. So that's when you differentiate and let it equal to 0. So you're letting your derivative equal to 0 basically here. And so that is, so therefore my derivative is 0.003 x squared minus 0.24 x plus 3.6 is equal to 0. And the reason we're letting it equal to 0, don't forget, is that the slope at the maximum turning point on my curve is here, and the slope is always flat at a turning point. So that's the reason we're letting it equal to 0. And you can see here there's also a minimum turning point actually. So when we solve for x now, you'll see that you're going to get two values, but we just need to be sure which one we're taking as our final solution. Okay, so that's just a little bit of background anyway. So we have a quadratic equation here, so you can use your minus b formula if you want. I'm just going to keep factorizing it. So I'm going to get rid of my decimals by multiplying across by 1000. So you don't need to do this. You can go straight to your minus b formula if you wish. That's getting me 3x squared minus 240x, so 240x, plus 3,600 equals to 0. I then see that there's a 3 common, so I'm dividing across by 3, which is giving me 1x squared minus 80x plus 1,200 equals to 0. Now the question is giving me a bit of a solution here. It's telling me that one of my values is x is equal to 20. So when I factorize this, a little bit of common sense here is telling me that one of my original factors must have been x minus 20, because my root is x equals to 20. And 20 multiplied by what is 1,200? Well, 20 multiplied by 60. So my other factor must be 60. Minus by minus gives me a plus 1,200, and minus 20 minus 60 is minus 80. So my two roots are x is equal to 20 and x is equal to 60. Now, if you look at your graph, you can see that they are both the turning points on the graph. One's a minimum and one's a maximum. I'm going to use my mathematics to show which is minimum and which is maximum now. So now show max and which one is min. That's all I'm doing now. In order to do that, you differentiate again. You find the second derivative. So I'm differentiating 0.003x squared minus 0.24x plus 3.6. And that is getting me 0.006x minus 0.12. And the rule tells us then we sub in our values for x. So I'm going to let x is equal to 20 and let x is equal to 60. So all I'm doing here is I'm proving which one is the maximum. And when I sub it in, I get 0.006 multiplied by 20. So I'm subbing in my 20. And on my second one, 0.006 multiplied by 60 minus 0.12. And when I evaluate both of those, I'm getting minus 0.12 and positive 0.12. And when you get your negative solution, that is your maximum value. And when you get your positive solution, that's the minimum value. So show that this section of track reaches its maximum height above level ground when x is equal to 20. Well, we have just done that there now. So we didn't need the right hand side. All we needed to do was sub in the 20. But look, it's good to verify that 60 was not our solution. Okay, that's B part 2. Scrolling down now to B part 3. It's asking us to find, using calculus, the height above ground in meters at the instant the track passes through an inflection point. And they've just given us the function there again. Now, point of inflection is always found by finding the second derivative of the function. So that's how you find the point of inflection, and you let that equal to 0. Now we have the point of inflection from, we have the second derivative from part 2, and we found it to be 0.006x minus 0.24. So we have that. And to find the point of inflection, you let that equal to 0. So I'm letting it equal to 0 and solving this equation. And what I'm going to do now is I'm just going to move the constants to the right and x's on the left. So I'm adding 0.24 to both sides. So 0.006x is equal to 0.24. To get x, I'm dividing across by 0.006. So 0.24 divided by 0.006. And that divides in 40 times. Now, a point of inflection must have an x and it must have a y. I found my x, now I must find y. And in order to find y, I sub it back into my original function h of x. So I'm taking back now my original function. Just be careful here what you're always subbing back into, because you're working with the original function, you're working with the first derivative, and you're working with the second derivative. So just take your time. And I'm subbing in h of 40. So 0.001 times 40 cubed minus 0.12 times 40 squared plus 3.6 times 40 plus 5. So I'm just putting my 40 in a different color there to see that I'm substituting in that value. And when I work that out in my calculator, I'm getting a value of h of 40, which is y in other words, of 21. So therefore, let's write it out here, my point of inflection is going to be 40, 21. And the final part is part C. Use the function h of x once again to find the average height of this section of track above level ground from x0, x75. So the key word here, or key words, is average height. Give your answer in meters, correct at 2 decimal points. So this is your average value. So we're into our integration here. Your average value is found by going 1 over b minus a times the integral. So we're going from 75, the highest value, to the lowest value of 0, of 0.001 x to the power of 3 minus 0.12 x to the power of 2 plus 3.6 x plus 5. So first thing I need to do now is integrate that h of x, and my a and my b is 75 and my a is 0. So it's 1 over 75 minus 0, and I'm multiplying that then by my integral. Now when I integrate it, I increase my power and divide by my new power, so 0.001 x to the power of 4 all over 4 minus 0.12 x to the power of 3, so I increase my power, divide by my new power, 3.6 x to the power of 2, divide by my new power, plus 5x, divide by my new power. Now you don't need to put in your constant here, because in a second we are going to be subtracting when I sub in 0 from the 75. So you're just going to have c minus c, which will cancel. So I don't bother putting in the c, but you can if you want in these. So that is giving me 1 over 75. And I'm going to just do a little bit of shortcuts here if you don't mind. What I'm doing here is I'm going 0.001 times 75 to the power of 4 all over 4 minus, and so on and so on. I'm basically subbing in 75 for x. Then what I'm doing is I'm going to subtract me subbing in 0 for x. 0.001 times 0 to the power of 4 all over 4, and so on and so on and so on. So I'm just going to cut a little bit of a corner here just for speed, that I'm not going to bother subbing them all in. But that's basically the process here. So I'm subbing in my 75, subbing in my 0, and I'm taking them away from each other. So that's going to leave me with 1 over 75. And when I go to my calculator and I do the subbing in for 75, I got 1,535.15625. And when I sub in 0, I just get 0, because x is being multiplied by a coefficient and x is 0, so 0 by anything just gives me 0. So that's 1 over 75 times 1,535.15625. When I multiply that together, I'm getting 20.46875. The question wants it to 2 decimal points, so that is equal to 20.47 meters. So the average height is 20.47 meters. And that's our solution. Question 9a. A cup of coffee is freshly brewed at 95 degrees centigrade. Temperature T in degrees centigrade of the coffee as it cools is given by this formula. A is constant, T is the time measured in minutes. Part 1, show that A is equal to 75. So what we're going to do with this part, let's just put down our formula here for the cooling of the coffee. So it's equal to A e to the power of minus 0.081 T plus 20. So what we're going to do here is we're going to look at the cooling of the coffee exactly when it was brewed. And imagine it's like a stopwatch. You start your stopwatch exactly when the coffee is brewed. That means that T, or time, is going to be 0. So all I'm doing here is I'm subbing in 0 for time, for T. So that's A times e to the power of minus 0.081 times 0 plus 20. 0 times minus 0.081 is 0, so that's time of 0 is equal to a times e to the power of 0 plus 20. Time 0, now we know when the coffee is brewed, the temperature of the coffee is 95 degrees. So I'm just going to change that to 95. That's the temperature of the coffee at time 0 is equal to a times e to the 0. E to the 0 on your calculator is 1 plus 20. So that is giving me 95 is equal to 1 multiplied by a plus 20. I'm going to subtract 20 from both sides, or move over that 20, which is 95. Subtract 20 is equal to 1a. And 75 is equal to 1a, or a. And that's what the question wanted us to show. Show that a is equal to 75. Looking at part 2, explain what the value of 20 in the formula represents in the context of the coffee cooling. Well, the 20 is the constant, first of all, so I'm just going to put that down. 20 is the constant. And what that basically means is that it would be the room temperature. So if you leave that coffee out for infinite time, it's still going to remain at 20 degrees. So in other words, it's the room temperature. So I think that's enough for part 2. Part 3, find the decrease in the temperature of the coffee 10 minutes after brewing. Give your answer correct to the nearest whole number. So again, it's always good practice to put down your formula here again. Is equal to a to the e minus 0.081 times t plus 20. Actually, I'm just going to sub in my value now for a. My value for a from part 1 is 75. And they're looking for the temperature, the decrease in the temperature after 10 minutes. Well, first of all, we need to find t of 10. So what is the temperature after those 10 minutes? So times e to the minus 0.081 times t, and I'm subbing 10 in for t, plus 20. And that is giving me t of 10 is equal to 53.36 degrees. Now that's the temperature after 10 minutes, but they wanted to decrease after those 10 minutes. So the original temperature is 95 degrees. And I'm now going to subtract the temperature after 10 minutes, which is 53.36 degrees. So the decrease in the temperature is 41.636, which gives me, to the nearest degree, 42 degrees. Okay, so that's 9 part A, 1 and 2. Now looking at part B to that question 9. So again, they've given us the formula for the temperature of the coffee. If the ideal temperature to drink coffee is 82 degrees Celsius, find the time to the nearest second that it takes for the coffee to reach this temperature. So again, I'm now going to sub in for capital T of time, I'm going to sub in the temperature that's desired, 82 degrees. So that's what I'm given, or that's what I want. And what I'm trying to do here is I'm trying to find the time. So I'm solving for T. So that's going to equal 75 e to the power of minus 0.081 t plus 20. So a little bit of algebra here. I'm first of all going to subtract 20 from both sides. So follow your rules of BIMDAS here for the orders. So 82 subtract 20 is equal to 75 e to the power of minus 0.081 times t. 82 take away 20 is 62, is equal to 75 e to the power of. I'm now going to divide across by 75, so divide both sides by 75, which is giving me e to the power of minus 0.081 t is equal to 62 over 75. Now I'm going to go to my log tables now, and I'm going to use page 21 for my logs, and I'm going to use one of the little rules there, the top right hand corner, which has the following: a to the power of x is equal to y is the same as log of y to the base a is equal to x. So I'm going to use this formula now to solve for t, for time in my particular question. So that's giving me the log of 62 over 75 to the base e equals minus 0.081 t. And the log of 62 over 75 to the base e on my calculator is minus 0.19. And in order to solve now for t, I'm going to divide both sides by minus 0.081. So then that is giving me t is equal to 2.35 minutes. Now the question wants us to find the time to the nearest second. So I need to turn 2.35 minutes into seconds. Well, 2 minutes is 60 seconds plus 60 seconds. And to turn 0.35, just go to your calculator and multiply 0.35 by 60. And that's giving me 21 seconds. So it's 35 over 60 basically, which is giving me 141 seconds. Or just go to your calculator and multiply 2.35 by 60. That's part B. Looking at part C, find to the nearest degree the temperature the coffee has reached when t dash of t is equal to minus 4.05, where t dash of t is the rate at which the coffee is cooling. So you can see a couple of keywords there: rate of change. T dash is your first derivative. So they're talking calculus, differentiation here basically. So first of all, we need to find what is the derivative of the formula for time. So we have to find t dash of t. So we have is equal to 75 e minus 0.081 t plus 20. I'm going to go to page 25 now for my log tables to help me differentiate 75e to the power of minus 0.081. We know that the plus 20 is my constant, so that'll just drop. Now when I differentiate it, it's going to give me 75 times my power, which is minus 0.081, times my e to the power minus 0.081t. So that's a 1, 2, 3. It's the fourth rule down there on page 25 in your log tables, how to differentiate e to the power of a to the x. So when I multiply 75 by minus 0.081, I get minus 6.075 e to the power of minus 0.081t. So that's the derivative. And it's telling us in the question that my derivative is equal to minus 4.05. So therefore, minus 6.075 e to the power of is equal to minus 4.05. And I now need to solve that. So I'm going to divide across. Again, the aim of the game here is to solve for t, the time. So I'm going to divide both sides here by minus 6.075. So a lot of this is calculator work here. So they'll become 1, which gives me e to the power of minus 0.081. And from here on in, actually, it's very similar to part B, which simplifies to 2 over 3. So it gets a little bit easier there. And look, we're going to go for the same approach here to solving this. So from page 21 in my logs, I'm using the rule a to the power of x equals y is the same as log of y to the base a equals x. And I'm just going to come up here and we're going to solve that out. So that is giving me log of 2 over 3 to the base e is equal to minus 0.081t. Log of 2 over 3 to the base e is giving me minus 0.405465. I'm going to divide both sides now by minus 0.081, so that'll cancel 0.081. And when I divide that in, I'm getting 5.0057 is equal to t. So that's not the end of the question, because the question said find the nearest degree the temperature of the coffee has reached at 5.0057 seconds. So we now need to come back. So therefore, coming back to my original formula, which is 75e to the power of minus 0.081t plus 20. And I'm now subbing in my time of 5 seconds. Now you can go to one decimal place, I'm sure is fine. I'm just going to keep it here with the decimal. So that's 75e to the power of minus 0.081 times t. Well, look, let's just put in the 5 here because it's going to 2 decimal points with 0. So I think it should be thereabouts, which is going to give me, when I solve that, 70 degrees. So you have to solve for t first of all, and then you need to sub that time in because the question wants us to find at which the coffee is cooling in degrees centigrade per minute. So they wanted us to find the degrees of the coffee. Okay, that is part C. There's one last part to this question, and it's part D. So a sugar cube is put into the coffee. The sugar keeps its cube shape as it dissolves. As the sugar cube dissolves, its volume decreases at a constant rate of 1/20th centimeter cubed per second. Let x of t be the side length of the cube at a time t. Find the rate of change of x of t when the volume of the cube reaches 1/64th. Okay, so we have a bit of work involved in this one by the looks of it. Let's look at our ice cube first of all. We need to do a little bit of working out with our cube. So let me just sketch it here and see what's going on with it first. And it's telling us that the cube is decreasing at a rate of 1/20th, but it says the rate of change when the volume of the cube has reached 1/64th centimeters cubed. So that's the volume of the ice cube that we want. Now it's telling us that the cube keeps its shape as it dissolves. So that means it's a cube. So all 3 sides are going to be the same. So length, width, and height. So in order to get the length of a side, I'm going to find the cubed root of 1/64, which is giving me a quarter. So that's telling us here that the x is basically 1/4. So therefore x is equal to 1/4. So a side of my ice cube is 1/4. So that's one thing we know. We also know that the volume of the ice cube is given in terms of x, so that would be x by x by x. So the volume of the ice cube is x cubed. And if we were to differentiate, because we're going to need it here because it's talking about rate of change, so that's volume is equal to x cubed. To differentiate the volume, dx dv would give me, dv dx I should say. dv dx is equal to, when I differentiate that, I get 3x squared. So we're going to need that, I think. So let's just keep that here because it's going to come in handy. What else do we know? We know that the sugar cube dissolves, its volume decreases at a constant rate of 1/20th centimeter cubed per second. So that's the same as dv dt, the volume with respect to time. So that's getting us 1/20th centimeters cubed per second. Now it's dissolving, so it's getting smaller. So what I'm going to do there is I'm just going to call my dv dt, I'm going to relabel that as dv dt is equal to minus 1/20th because it's decreasing in size, my ice cube. So we have a bit more information there. Let's look now at our rate of change. Our standard rate of change, or how you would call it anyway, rate of change is known as dy dx. So this is just a general form, is equal to dy over my rate times my unknown over dx. So that's just your standard rate of change. We need to fill that in according to our question. So if we look at our question, it's now going to be dx dt. That's what we need to find. They're asking us to differentiate the rate of change of x of t, because rate of change is the derivative. So that's what they want us to differentiate. So that would give me And instead of calling it dy over unknown, it would be dx over my unknown, which is my volume of the ice cube. So dv times my unknown, which is my dv, and my dx in this case is my time, so dt. So this now is what I need to fill in. And when I fill that in, what do we get? So we have dx over dt is equal to dx dv. Now I have here dv dx, so I just need to find the opposite of that. So I'm just going to flip my fraction there basically. So the opposite of that is going to be dx dv, which is flipping the fraction. So 3x squared over 1 becomes 1 over 3x squared. So that's just a little bit of work to that box there. So that's equal to 1 over 3x squared. And what else do we know? That is now times my dv dt, and we have our dv dt here, which is minus 1/20. Okay, when I multiply those two fractions together, 1 over 3x squared times minus 1 over 20, I get dx dt is equal to minus 1 over 60x squared. And that is now, I need to sub in my x. We know that x from the very start is 1/4 from here. We solved that, or we found that, which is 1/4. And I'm going to sub that in, so therefore minus 1 over 60 times 1 over 4 squared is going to get me minus 4 over 15, and we are now talking in centimeters per second. So find the rate of change of x of t when the volume of the cube reaches 164 centimeters cubed. It's the rate of change is minus 4 over 15 centimeters per second. That is question 9 complete. Question 10a, water is flowing into and being removed from a tank. The volume of water in the tank is measured on a daily basis starting at day 0. The volume of water in litres in the tank can be modelled by this formula, where t is an element of the real numbers, is the time in days starting at day 0. Use the function for the volume to answer the 4 questions. So part 1, find the value of t when the tank empties. Well, when the tank empties, the volume is obviously going to be nil or 0. So that means that my formula from volume can now be 0 for volume equals 60 plus 41t minus 3t squared. I'm just going to rearrange that with the power of 2 degrees first. So minus 3t plus 41t plus 60 equals 0. And I don't like having a negative in front of my t squared, so I'm just going to change the signs across the full equation. So therefore that's the same as positive 3 squared, negative 41 t, negative 60 equals negative 0, or just 0. And I'm going to factorize that for t, so you can use your minus b formula, your guide number, but the factors are 3t and t, and 4 multiplied by 15 would give me 60, and a positive 4 and a negative 15, because negative 15 times your 3 would give you 45, plus the 4 would bring it back to 41. Yeah, so there are your factors. And I need to find the roots, so therefore 3t is equal to negative 4, t is equal to negative 4 divided by 3, and I also have t is equal to positive 15. Now I'm going to ignore the first one because I can't have a negative time. So my answer therefore is going to be t is equal to 15 days. And that's part 1. Part 2, find the rate at which the volume of water in the tank is changing when t is 5. So this has got to do with rate of change, which brings my attention to calculus, differentiating the function. So let's write down the original function. So the formula for volume at a specific time is 60 plus 41t minus 3t squared. I'm going to differentiate it, so that is giving me the 60 is the constant, which will drop. 41t differentiated becomes 41, and minus 3t squared becomes minus 6t. And I need to solve that when t is 5. So subbing in 5 for t gives me 41 minus 6 times 5. 6 5s are 30. So 41 minus 30 is 11 liters per day, because time is in days and the tank is measured in liters, I think. So 11 liters per day. Part 3, find the value of t when the volume of the water is at its maximum. So there's the key word here, is maximum, which is like your minimum and maximum turning point. So that's when you have to differentiate and let it equal to 0, because it would be the minimum or the maximum turning point in this case. So once again, I'm going to go through all of the steps. So your formula for the original volume is 60 minus 41, or sorry, plus 41t minus 3t squared. We differentiated that from up above, and we got 41 minus 6t. The maximum turning point is when the slope is 0, so I'm going to let that equal to 0. Solve for t, which is minus 6t, is equal to negative 41. I'm going to divide both sides then by minus 6. So t is equal to minus divided by minus is a positive, 41 over 6, which is giving me approximately t is equal to 6.83 reoccurring days. So about 6.8 days. And the final part to part A is part IV. Find the maximum volume of water in the tank correct to the nearest litre. So this is using part 3 here, because you're finding the maximum volume. We've got the time when it's at its maximum, which we said was 8, or what did we say there in the previous part? We said it was 6.83, or let's keep it as a fraction. 41 over 6 days is what we got from part 3 of this question. And all I'm going to do there is I'm now going to go back to my original formula for volume, which is 60 plus 41t minus 3t squared. And all I'm going to do is, in order to find the volume when the time is at its maximum, I'm going to sub in my 41 over 60 for t. Sorry, 41 over 6, I should say. And that's giving me 60 plus 41 times minus 3 times t squared. And I'm subbing in 41 over 6 and 41 over 6. And when I put that on my calculator, I'm getting a maximum volume of 200.08 liters. Question wants it to the nearest litre, so therefore my maximum volume is 200 litres. Okay, that's part A. Pushing down to part B, which is basically a different question altogether. Trees of the same age, size and type are grown at the same rate in a forest. It is possible to measure the radius of the trunk of a tree at the end of each growing season. The increase in the radius of the trunks of these trees each year in centimetres during a particular 10-year period can be modelled by this formula. So it's a trigonometric formula here. And they've given us a little bit of information about radius 1, radius 2 and radius t plus 1. Where radius t is the radius of the trunk after t years, and radius 0 is the radius of the trunk of the tree at the beginning of year 1. Okay, so a lot of information there. In part 1 it says, in order for the model to be reasonable, it must satisfy a number of conditions. One condition is written below, and it's saying the radius of the trees is increasing year on year. Show that radius t satisfies this condition. So show that the radius is increasing year on year. Okay, so the formula that we're given is I is equal to 1.5 plus sine pi times t over 5. Now, we know from our studies of trigonometry that a function can be written as y is equal to a plus b sine times c of x. So that's your general form here. And if we just kind of match these up, my a is my 1.5, my b is the number in front of the sine, which would be 1, and my c would be my pi in this case. My x would be my t. So I'm just matching up the general form here. So from that, we can conclude that if we take A minus B mod, so the positive value of B, it is the minimum value of the trigonometric curve. So what that means here is that if we were to do a quick sketch of it here, it's a sine function and it's crossing at 1.5. So it's looking something like that. Now what they want us to prove is, why is this graph not crossing the x-axis? Why is it not going down to the negative? And the reason for that is that, as I said here, if A minus the modulus of B is positive, so my B is the number in front of the sine, which they're not showing, which is a factor of 1 basically. So that basically is just telling me that A is my 1.5, and I subtract the factor of the sine, which is 1, which is giving me 0.5. And we know, obviously, that 0.5 is greater than 0. So, in other words, the amplitude is going down 1 unit to get me to 0.5. So it's never going to cross that x-axis. So it's all got to do with basically your range of the trigonometric function here. So therefore, 0.5 is greater than 0. So hence, increasing year on year. So it's never crossing the x-axis. It's never going into a negative figure. Okay, so that's part 1. Part 2 wants us to show that I6 is less than I5 and explain what it means in the context of the growth of the trees. So all we're doing here is we're basically subbing in 6 and 5 into our formula. So here is our showing of our work. So I to the 6 is equal to 1.5 plus sine times pi, subbing in 6 for my t over 5, which on my calculator is giving me 0.9122. Going to do the same steps for I to the 5, which is giving me 1.5 plus sine pi times 5 all over 5, which is giving me 1.5. So explanation, so I'm just going to conclude first of all. So therefore I to the 6 is less than I to the 5 because we've just shown that 0.9 is less than 1.5 if we just go to one decimal point. And explain what this means in the context of the growth of the trees. Well, let's see. This means that the rate of increase in the radius, or the growth of the trees basically, we'll just say the radius of the trees, is slowing down. Or in other words, what else could we say? We could say the increase in growth in year 6 is less than the radius growth in year 5. So just make sure you make some reference to year 6 is less than year 5 and make reference to the fact that it's about trees and their radius. Okay, that's part 2. Let's have a look at part 3 now. Again, it's text heavy here, so maybe just take a minute or two to read it ourselves first. Okay, so basically what it wants us to do is find R2 of the radius of the second tree at T2. That's basically what they're getting us to do here. Now from the start of the question, from the previous page, it tells us that R2 is found by adding R1 plus I to the 2. So that's what it's telling us there on the previous page. Now that is also the same as, well, we know that R to the 1 is found again from the previous page by going R to the 0 plus R to the 1. So that's from the previous page. And then we need to add on our I to the 2. So I'm just basically breaking up what that's asking us to do. So R to the 1 is the same as R to the 0 plus, sorry, not R to the 1, that should be I to the 1 here. Okay, so basically what I need to do is, therefore, I need to find R to the 0 plus I to the 0 plus I to the 2. That's basically what this question is now asking me to do. Now they want us to give our formula, our answer in the form of our trigonometric function there, so don't turn it into decimals. So let's see what that's turning out. So R2 is equal to R0, which is 10, plus 1.5 plus sine times pi to the 1 all over 5. So that is basically finding me R0 plus I0. R0 is 10, I0 then is my formula there. Then I'm going to add on my I to the 2, which is going to be plus 1.5 plus sine times pi multiplied by 2 over 5. So that's my I to the 2. I'm now going to add them together. So in my first red boxes there, the 10 and the 1.5, just running out of space here, will give me 11.5 plus sine pi over 5. So 1 by pi is just pi over 5. And then I'm going to add on my 1.5, this is my I to the 2 now, plus pi by 2 is giving me 2 pi over 5. I need to add them together, so I'm just going to add the 11.5 and the 1.5 together, which is giving me 13 plus sine pi over 5 plus 2 pi over 5. So I can't add my signs there together because they're different. And that's my answer. So therefore, R to the 2 is equal to 13 plus sine pi over 5 plus 2 pi over 5. And that's what the question wanted it. It wanted in the form a plus sine b pi over 5 plus sine c pi over 5. And that's what we've got there. My a is 13, my b is 1, and my c is 2. Okay, last part of this question is part IV. At time 10, the second tree was also cut down. A section of its trunk in the shape of a cylinder of radius 10, standard length h, and volume V2 was also sent to a sawmill. If V2 is equal to K times volume 1, find the volume of K. So basically it's telling us that in order to find the volume of tree 2, we multiply the volume of the first tree by the scale factor of K. Now again, the question here is telling us that they're both cylinders. So that means then, so my smaller one, or my large one, so let's go V2 is equal to K times V1. And I'm going to call the volume of V2 pi r squared h, because that's a cylinder. That's my formula for a cylinder. And that's equal to the smaller tree, pi r squared h, also multiplied by the scale factor of K. Now, I can do a simple crossing out. There's a pi common to both sides, cancel them out. There's a h, the same height of the tree to both sides, cancel them out. So that means then r squared from my larger tree trunk is equal to k times the radius of the smaller tree trunk. Now I can't obviously cancel out those r's because the radiuses, or the radii I should say, are different. Okay, now what else do we know? We know that the radius of the smaller tree trunk at the beginning of the first year is 10. So I'm just going to write here a little bit of notes. Beginning of first year, or is equal to 10. So they've told us that up at the top of the page here. So we know that. So therefore, R2 is equal to K multiplied by the radius of the smaller trunk, which is 10 squared. And that's giving me R squared is equal to 100 K. Okay, so we've broken down as much as we can there. We now need to find the radius of this larger tree trunk. And what, again, I'm going from the previous page here, R squared is the same as R times T plus I. So that's coming from the previous page where you're trying to find the radius at a specific time. And that's the same as R to the T plus I to the T plus 1. Again, coming from the top of the first page here. Now we're looking for time 10, so that's the same as, instead of calling it t plus 1, it's 9 plus 1, which is 10, and that's equal to r to the 9 plus I to the 10. Now I still haven't forgotten my 100k, I'll come back to that in a couple of minutes. All I'm trying to do here is break out the radius of this tree. Now we can keep going back from there. We now know that r to the 9 is the same as r to the 8 plus 1 plus my I10, and then I break down my r to the 8 plus 1, which is r to the 8 plus I to the 9 plus I to the 10. So you can hopefully see a pattern occurring here. I just need to keep breaking down my r to the t plus 1 until I get something like this. R to the t plus 1, which is my r to the 10, is basically going to equal 10, my original radius, plus my I to the 1, plus I to the 2, plus I to the 3, so on and so on and so on until I get I to the 10. So that's basically what they need me to find here. Now there's probably other ways of doing it, but that's the way I've spotted how to do this question. So what I'm going to do here is I'm going to do out I to the 1, I to the 2, I to the 3, I to the 4, and so on up until I to the 9 and I to the 10. Now when I put 1 and so on into my trigonometric formula, I'm going to get, so therefore r to the 10 is equal to my original radius, which is 10. I put in 1 into my trigonometric formula, I get 2.09. I put 2 into it, I get 2.45. I put 3 into it, I also get 2.45. I put 4 into it, I get 2.09. I put 5 in, I get 1.5. I put 6 in, I get 0.91. I put 7 in, I get 0.55. 8 in, 0.91, and so on. So that's my 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, so I have 10 values there for the 3. Just looking there, I think I forgot term 8 there. So that was 0.55 as well. The 9th I to the 9 is 0.91, and then 1.5 for I to the 10. Okay, when I add them together in my calculator, I get a radius of total of 25. So therefore, remember from this part here, r squared is equal to 100k. I've now got r to be 25, so that's 25 squared is equal to 100k. 25 multiplied by 25 is 625 is equal to 100k. And to solve for k, I divide both sides by 100. So that's getting me k is equal to 6.25. Now, like I said, there's probably different ways of doing it, but that's how I spotted it.